Good afternoon. This session is done by really SNIA Technical Council. My name is Siddhartha Nandi. I am part of the SNIA Technical Council. We are going to talk about a proposal for a SNIA SIG, special interest group in this particular area. I am from NetApp. I have my colleague Dr. Jayanta Basak. He is in a very exclusive company of the ACM Distinguished Engineer, which is an internationally recognized set of people by the largest professional body in our profession, that Association of Computing Machinery, ACM. So this is the last, probably the session in the track-wise. So you have seen enough of this presentation and slides. So I do not have many slides. The idea is that it's a proposal for a special interest group, and I would like to know what kind of interest this particular area you have, and we'll be kind of noting it down, and then we'll ask for contribution. How do you kind of start this process? But to start the discussion, I have got few slides to kind of motivate and kind of see that what kind of problems we are going to talk about. Okay, why now? So machine learning is, as someone says, it's a common buzzword. Buzzword or not, there are views about it, right? Sometimes buzzword is used rather in a derogatory fashion. So I do not think machine learning is of that type in today's world, because it has proved itself in various contexts in a way which was probably beyond people's thinking about 5 years back. Biggest example is that no one thought of in 5 years self-driving car will be a reality, right? Even 5 or 6 years back, these were done mostly in the US university projects as some curiosity projects or some kind of a project people do when they are at the college. And from there, it has become a reality where actually the many cities are utilizing those kind of technology. And machine learning, as you know, is very much beyond it. There are various other examples of machine learning becoming a real-world problem solver. So that means that these technologies have matured really because of those internet-scale companies like Google, Amazon, Microsoft, IBM, etc., contributing heavily towards this. And that was mostly driven because they have got very large data systems, and also they are collecting lots of data from the usage of the system to kind of solve various system-related problems. So if we translate that to storage systems, that's what we also have got a very large storage system nowadays deployed. They collect not only store or manage the supplied data, they also generate a lot of data about their system usage. It's like that how Google has got its click stream, that whenever we click, I understand almost one kilobytes of data getting generated about various features, and which is transmitted to, say, Google. And from there, it can mine that data using this type of mature technologies to generate various types of insights. Similarly, most of these complex storage systems, and not only the storage systems, software systems, generate their version of clickstream data, meaning that they have got lots of instrumentation or telemetric data which they collect to kind of explain or rather monitor how the system is being used. So why not use this kind of mature technology as used in big data problems, as this is also kind of at a somewhat smaller scale, similar to big data problem. So that's what, from the technology angle, these things are important. And these storage systems are becoming very large, and so this, I think one slide is missing. Okay, sorry. So this is what the motivation. Yes, please.
Yeah, so one example for machine learning with storage. Any example?
Oh yes. Yes, Jant. One example which actually is being deployed today, I don't want, so I'm from NetApp, so I know little bit of it. So I can tell you that, no, you might have seen in that swordfish, this one other, one thing is that, no, class of service, right? A class of service is the what kind of, you have got various types of applications running, and you will require various types of storage services to be provided to those applications. These are in general a class of service concept. Now, when you go to an existing data center, okay, so how do you kind of find out that what is the optimal set of class of services the data center is providing today? If you have got, say, hundreds of applications with thousands of storage pools around, it is very difficult to handle it manually, right? As a matter of fact, we have developed a machine learning applications which can find out that what's the optimal set of storage services which will cover your current set of applications. Just from the telemetry data, the system itself is generating about the usage of those applications. Another example outside of this, Nutanix has built within its system, MR framework, MapReduce kind of framework, and they are using Q-learning to, which is a kind of reinforcement learning technique, to schedule various types of activities so that they are not interfering with the original user jobs. There are other examples. As we proceed, we'll go. Sorry. So this is the agenda we want to. I think this is better before we move to the agenda. So you are saying that what are the types of problems? So Jayanto is going to talk about those problems.
So here we.
I think so.
Here we jotted down a few class of problems. This is obviously not does not encompass everything, but some 3 or 4 classes of problems. And how we want to show is that what is the broad type of problem and what kind of data we really want to have, telemetric, and there are other data, there can be other data also. And what kind of ML techniques, if you ask, we are touching upon various of these things at NetApp. There are some examples, but those are not. Many things can be done. So first is provisioning resource planning. So provisioning, we know what is provisioning, but be it in cloud or large data center, dynamic provisioning or resource planning is very much essential. So how to provision dynamically? That's a very difficult problem. A workload is running, you want to move to some other place. So how do you know what will be the performance in the new place and how you can allocate? So can we estimate? This is a kind of regression problem, but not really regression problem. You have to estimate in future what will happen in the future. So it is not what you have seen. You have seen some part of the graph and how the graph will extend the future. That is the problem that we have to estimate. So there are many types of data like telemetric data, which is essentially performance counters, like whatever you can think of IOPS, latency, throughput, and other read-write ratio, and all these things, and configuration data and kind of utilization metrics. So we can come up with different types of utilization metrics. This is not only CPU utilization or disk utilization or whatever. This is also kind of performance utilization. How much it is, what is the performance it will derived. So various ML techniques are involved in this. Regression, as I mentioned, then reinforcement, Siddhartha mentioned. Then obviously dimensionality reduction is that it's a huge volume of data. We collect more than 10,000 counters, so obviously most of them are not meaningful here. So which counters are really useful? Then this is obviously an optimization problem, how to allocate your resources to the thing. So this is the overall flavor. So there are lots of innovations are possible in this area. Similarly, root cause analysis or troubleshooting. So, one example, suppose you are seeing performance counters and you want to identify this is the anomalous zone of the
no, it is on.
So one project was done at NetApp. So you are observing performance counter. You want to see what are the anomalous regions. So it's a kind of, you can see you are detecting anomaly in time series. And can you identify, can you correlate that with some system issues? Or even logs. These are the logs and these are anomalous log messages. Can we root cause why this is coming? What is the problem? So that requires a lot of understanding of what is the normal behavior and what is the abnormal behavior. Nobody will be able to tell what is a normal behavior, but it has to be extracted from the data. And extraction of from the data requires machine learning technique. Similarly, we developed some Bayesian framework to predict that something is going to be wrong. So these are very small examples, but this is a very broad domain. Similarly, there are another two categories, early warning. So early warning is the counterpart of troubleshooting, whether we are able to predict the problem early enough so that that can be mitigated, certain actions can be taken. So taking the action is very difficult, automated action, but possible. It's not that it is impossible. It is possible. So again, so I brought Bayesian networks. Note that yesterday there was a deep learning. Now people talk deep learning in every context, but this existed actually before also. So optimization, time series prediction, these are the techniques required. And the last category is tiering caching. So tiering caching is a very broad area. It is not only caching. For example, you want to design a power efficient storage where from the access pattern you decide that these particular objects are accessed in this pattern and rest of the time I put that off, or I can use a kind of storage which will not be on for that time period. So how to put it on and off? That's also a learning problem. But that's a very small example. There are many others. So you have memory hierarchies, how to efficiently distribute your data across the different layers of cache so that you get maximum heat, which is sitting near to the processor, which is sitting one next layer. So there are many such things. So there we require traces counters and then some configurations. And obviously, reinforcement learning will be required if we do a mistake, how to take corrective actions, deep learning, optimization, and clustering. So that is the thing.
Any other questions or any other areas you want to look at? Sorry. There is a question to the audience. Sure.
How do you see load balancing versus machine learning?
Load balancing, actually there are load balancer already available which look at a very short term data to do the load balancing. For long term, yes, there is kind of no workload optimization. So that workloads, when we say that when an application is running on the system for a longer duration, not like this your each request kind of things, right? So how do you kind of distribute the workloads in a way so that your storage systems is optimized better, right? So those kind of applications is in the purview of machine learning. So that's also kind of things. Yeah, and that is what now the agenda of this special interest group in machine learning I am proposing is that develop broad understanding of the problem area before we kind of really jump in to know what exactly we do. So various types of things we can build some kind of a POC or some kind of even on paper model of this type of problems to get a better understanding of these problems. And all these are very data driven, and storage systems, various storage systems also have got all types of this type of data, but they are not compatible. So we have heard number of sessions. The Swordfish has come, SNIA Swordfish specification has come up with this scalable storage management for that various interfaces. Now those interfaces are very useful, but all of them requires that individual storage administrator to actually execute those commands. When you have got a very large system, so how many commands you will do it? So the person becomes the bottleneck. So if you can do many of these things automated using these kind of techniques, right? So those will really add value to the scalable storage management and make it a reality in terms of scale, right? So you have got the infrastructure to do those things at scale, but you need this kind of advanced techniques to kind of realize that scale. What people generally try to do is through this policy definitions, which are once again manually driven. And when you have got a large variety of systems, which is so much of dynamic changes going around, it is very difficult to fall into those kind of policies. The policies soon become outdated. So there also there is the scope for those, how do you kind of dynamically change those policies, how do you learn the policies from the system operations, and then you kind of apply those policies. Like I gave the example of the storage classes. Those storage, so as the technology changes underneath, and we have heard from various sessions that how the technologies are changing, so that your performance requirement or the applications requirements will change. So you will need to change this definition of the storage classes also appropriately. Now it will happen gradually, so people may not notice it. Whereas these kind of things can continuously monitor and adjust your system to such kind of changes in the environment. So that was the second point, is that how can we propose extension of swordfish kind of specification in terms of what kind of data storage system should collect and what kind of data format, so that applications can understand these heterogeneous systems and manage it better, as well as type of functionalities we should build in. Any question, feedback? Yeah, Sudhan.
So I think it's a wonderful thing. So why only storage management would be the first point? Why not look at devices or the platform area, or because there are multiple areas to look at also. So just a point so that we can get a understanding of it.
Yes. I have seen that the machine learning very soon becomes very broad-based kind of thing, because this is really a very abstract set of algorithms. You can apply it in various areas. So very soon people become now very excited about where else I can use. But I want to contain the scope so that we can deliver somewhere fruitfully. And secondly, I want to see also the SNIA's main focus is on storage networking and storage management, and so that is what I wanted to restrict the scope to this. There is no restriction as such to why not these kind of things can be extended. But I am not to other infrastructure component like CPU or networking. I am not an expert in those areas, so I can't really comment on that. Other thing I also restricted the scope further is saying that there are two planes in which these kind of systems work: data plane and the control plane. Data plane is where the actual IO path, where actual IOs are happening. There are scopes for machine learning, but machine learning by at least today's algorithms take a lot of CPU time, and IO path is quite sensitive to the usage of CPU time. So I wanted to make it in the control plane so that it is not impacting the IO performance. And control plane means it is mostly about storage and data management. And so we picked up a sample set of problems. There are more problems. There is also a separation between whether it's a proactive or reactive. Reactive means which is more of support kind of cases where system has developed some problem. Okay, machine learning can definitely help in identifying or at least speeding up the resolution of the problems. Or in certain cases, whereas what we have concentrating on is that the management part, which is more proactive, so that we can use this machine learning, its predictive and prescriptive kind of nature to predict the problems the system can face and prescribe certain solutions. Because if you just point out the problems, then people are not really comfortable with it. What do I do with the problem? And that's why I know that the prescriptive thing comes into, which is also very much into machine learning areas, right? Any other questions?
These sections would cover the data mining part of it as well, to understand what is going on today in the systems. I mean, I'm relating it to what I've heard of machine learning in the IT space, is that people are finding patterns which they've never thought of, right? So data mining or knowledge discoveries are helping with that. Now, the first question that comes to my mind is, are we in a position to understand exactly what metrics we have?
So when we talk about machine learning, it's machine learning, optimization, data mining.
Sorry?
I was going to say, isn't that a broad or a big subject?
No, the data mining and machine learning, sometimes they are indistinguishable depending on the application. If you are saying that data mining to discover new relationships, like people always give that example, no, that which product should sit on the shelf next to each other, right? That's the kind of a discovery, relationship discovery you are doing using data mining, okay? Whereas our is that now we know certain problems which are amenable to machine learning kind of techniques. So we'll use those set of problems to kind of see, rather than discover that what else is happening in the system. That a root cause analysis is kind of in that direction, right? But and that is reactive, so which we are, for the time being, we are not keeping that scope as broad as that everything under the sun I can do it today now in machine learning probably, right? We don't want to go there. Yes.
Actually, we have seen that during the sessions that machine learning needs a huge amount of data to learn from it. But consider as a small data, like a data center. If we try to imply machine learning, we may not have enough data set to learn from it. So does that mean that we will have to collect data from multiple data centers to implement machine learning?
That's a good question. That's why at the very beginning I said that the why now is that because the data centers have become very large, where you will have use for this. So that's exactly the point. Now that we are having that level of volume of data, and now the technology has matured. So both the things have kind of pointing out that this may be the right time to apply such things into data center problems. Otherwise, these problems, whatever we are talking about, has been there for decades in the data center. But and these machine learning techniques were also known for decades in the data center. Why we are able to use it now? Because both the things have happened.
So basically, the machine learning is also refined now.
Pardon me?
Machine learning algorithms have also refined now.
Yeah, right. They have matured because of this now internet scale companies. I'm running out of time, so if you think that this is an interesting agenda scope you want to work on with us, with SNIA, so please send a mail to either to me or Udayan, and we'll get back to you. We plan to do a public mailing list, which has not happened within this short time. So as soon as that is known, we'll let you know. But at least to see how many people are interested, and then we plan to meet more regularly so with those people who have a sign up, and then we can discuss and build a more concrete agenda.
Thank you. We're just about to start the panel
Yeah.
session.
Thank you. Thank you.